Greetings, dear learners. Welcome to the official YouTube channel of SRN International School, Jaipur, Rajasthan. I am Faculty of Chemistry at SRN International School. Today, in this video, I will be explaining Chapter 9, Force and Newton's Laws of Motion of Grade 9 Science NCERT. So in this chapter, we are going to study about force and Newton's laws of motion. A force is a push or a pull. Push forces. A push is a force moving something away from you. Pull forces. A pull is a force moving something towards you. So now let us study about the types of forces. There are two types of forces, balanced forces and unbalanced forces. Balanced forces are those forces that do not change the state of rest or of motion of an object. As you can see in the figure, there is a tug of war going on between the two teams. Now when the two teams are pulling the rope with the same force, that is 300 Newton on both the sides, then there is an equal force, that is a balanced force, which will not change the state of rest or of motion. That is called as a balanced force. Unbalanced forces are the forces that changes the state of rest or of motion of an object due to unequal forces on both the sides. As we can see in the second figure, in the tug of war, the two teams are there, but on the team on the left hand side is pulling the force with more force of 400 Newton as compared to the other one, which is having only the force of 300 Newton. So this becomes an unbalanced force, and this is due to the unequal force on both the sides. Newton's laws of motion. So there are three Newton's law of motion. Newton's first law, Newton's second law, and Newton's third law of motion. Newton's first law of motion also is known as law of inertia, and in this case the moving objects, they keep on moving, or the objects at rest, they stay at rest unless acted upon by an unbalanced force. Newton's second law of motion it is expressed by force which is equal to mass into acceleration. If more the force means more is the acceleration. If more is the mass, that will mean less is the acceleration. And Newton's third law of motion, also known as action-reaction, if an object exerts a force on another object, then the second will exert an equal and opposite force on the first object. Newton's first law of motion, also called as law of inertia. An object will not change its motion unless acted on by an unbalanced force. If it is in the state of rest, then it will stay at rest only. But if it is in motion, then it will remain at the same velocity. Objects with a greater mass have more inertia. It takes more force to change their motion. That is the reason that why the objects with a greater mass have more inertia. So let us take some examples of first law of motion. The first example, as we can see on the right hand side, when the card is flicked with the finger, the coin placed over it falls in the tumbler. So here the object, when it is at rest, will remain at rest unless a net force acts on it. Similarly, if we kick a football, it flies away, because that object, when it is in motion, will remain in motion unless a net force acts on it. But if we kick a stone of the same size with equal force, it hardly moves. So this is due to the inertia, which is a natural tendency of an object to resist a change in its state of motion or of rest. The mass of an object is a measure of its inertia. Newton's second law of motion. The Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. The second law of motion, we find that there is a change of momentum taking place where the force is directly proportional to the change of momentum upon time taken. First of all, what is momentum? Momentum is mass into velocity. And the if the ball is there and its initial velocity is u and final velocity becomes v at time t, then momentum in initial momentum of that ball will be given by as mu and final momentum is mv. So the change in momentum of the body is given as mv minus mu. Then rate of change of momentum will be given by mv minus mu upon t, where m is common here. And according from the Newton's second law of motion, force is directly proportional to the rate of change of momentum, that is mv minus u upon t. Now v minus u upon t is an acceleration. Therefore, F is directly proportional to m into a, where m is the mass and a is the acceleration due to acceleration of that body. So this is a mathematical expression of second law of motion, that is F is equal to ma. The second law of motion is often seen in action in our everyday life. Now if we consider a person moving a cart. Now in the first figure we see that a person is moving an empty cart, and the second figure along with it a person is also moving a cart which is loaded with the boxes. Now, if the force applied to these carts is same, that is both forces are equal, then the acceleration of the empty cart is greater than the acceleration of the loaded cart. But if this loaded cart, which has the lesser acceleration, has to be accelerated, then a large force will be applied. Therefore, the force is directly proportional to acceleration according to second law of motion. So here also, acceleration will increase when a large force is exerted. Newton's third law of motion. According to Newton's third law of motion, whenever one body exerts a force on another body, the second body exerts an equal and opposite force on the first body. That means it states that to every action there is an equal and opposite reaction. So the force that is exerted by the first body on the second body is called action, and the force which is exerted by the second body on the first body is called reaction. The third law of motion can be illustrated with many examples. Now, when we consider a person who is standing at rest and intend to start walking on the road, he accelerates, and this requires a force in accordance with second law of motion. So, the person pushes the road below backwards. The road exerts an equal and opposite force on his feet to make him move forward. Similarly, when a person jumps out of a rowing boat, he jumps forward, but as he jumps forward, the force on the boat moves it backwards, showing that to every action there is an equal and opposite reaction. Law of conservation of momentum. It states that total momentum before a collision is equal to the total momentum after the collision if no external force acts on the system. Now suppose we consider a ball 1 which is orange color with a mass m1, and ball 2 which is blue color is with the mass m2. Now if these two balls are traveling in the same direction along a straight line at different initial velocities, that is u1 and u2, then the momentum will be given as m1 u1 and m2 u2, which is the initial momentum of these two balls. Now when they collide with equal force but opposite in direction. And this is according to the third law of motion. And therefore, total momentum before the collision is equal to the total momentum after the collision. That means the momentum has been conserved. Now, the total momentum before the collision is m1 u1 plus m2 u2, which is before the collision. And this is equal to the total momentum after the collision, which is m1 v1 plus m2 v2. This is after the collision. So these total collision before and after the collision is equal. Therefore, we say that the momentum is conserved. And this is true for all the collisions between any objects, like a car and a truck when they collide, or two railroad cars, or a proton and a planet and a meteor. Dear students, I hope you must have understood the topic. Keep learning, keep exploring. Thank you for watching. Please like, share and subscribe to our channel for more informative videos.